The Chemical Database Service releases in January 2013. The system will initially provide access to a number of commercial databases, web-based access, for example, to systems such as the Inorganic Crystal Structure Database, the Accelerus Available Chemicals Directory, and in the very near future, DTherm. We'll also provide web-based access to public databases, specifically those integrated to the ChemSpider platform that the Royal Society of Chemistry has been developing for a number of years. We'll also provide access to structure-based prediction technologies such as ACD iLab. What we're trying to do initially at release is to provide solutions for chemists that they become used to. While we won't be providing all of the services that have been available from the earlier chemical database service, we are trying to provide access to reference data, physchem data, spectral data, crystallographic data, as well as those tools to predict properties for novel compounds. For example, NMR spectra, physchem data, the ability to generate systematic names such as UPAC names from input chemical structures, as well as to take systematic names and convert them back to chemical structures. Name to structure conversion fed out by ACD iLab. The initial services at release are those shown here. They will be the Cambridge Structural Database, ACD iLab, the RSC Graphical Database Collection, Methods of Organic Synthesis, Natural Product Updates, and Catalysts and Catalyzed Reactions. We'll also provide access to SPRESI Web, the Available Chemicals Directory, and ICSD. I'll give a few short overviews of some slides for each of these systems, except for CSD, because that will actually be running the software locally for you. SPRESI Web is a very, very useful database containing almost 12 million compounds, over 4 million reactions, and 32 million factual pieces of data extracted from over 500,000 references, including over 100,000 patents. This shows their website. We will provide some training videos as we move forward, but for now the simplest thing is to show the integration. So when we click through to SPRESI Web, I'd like to search for a molecule. Of course, we'll be able to support the structure searching, substructure searching that is already built into SPRESI Web. You can use the built-in editor, or if you have plugins for ISISDraw and ChemDraw, you can use that particular drawing interface. Simplest way to show you some of the results is to do a name-based search. For example, let's take 2,3-dibromothiophenone, fairly simple compound. Perform that search, see what we come up with. Here we find one molecule. Here's the compound. There's a whole series of suppliers, very similar to the type of information you would get from the Available Chemicals Directory. We're not comparing the two at this point. We've got the formula, molecular weight, etc. INSHI, which you can use for some of the searches in ChemSpider. Numerous names and synonyms. A long list. Keywords, physical properties. There are over 37 journal articles, and these click through to the articles, patents, other references, etc. As a reactant, and this is where the integration between the molecule and its presence in reactions, over 4 million reactions, we click through to the reactant position inside the reactions, and here we see a pile of reactions, again with the references. Again, this is not a complete review of what SPRESI Web will do, just an example of the type of information that will be delivered when we release the service on January the 2nd. Many of you will likely have heard of ChemSpider Synthetic Pages by this point. It's a micro-publishing environment that the RSC is hosting related to ChemSpider that allows people to publish their chemical syntheses and share them with the community. The reason I'm showing it this evening is because I want to show people how we could integrate this ultimately into the CDS system, the chemical database service that we're building for the UK community. Imagine, if you would, that you come to this particular synthesis and you see that this chemical is one that you would like to source from a vendor. In this case, what I'm going to do is launch the service on the chemical database service that links up to the EPSRC available chemical directory. Here all I've done is paste in the name, and I'm going to perform the search. This is a name-based search of the available chemicals directory hosted by EPSRC. We can also perform structure searches and substructure searches, but for now this is much simpler to copy the name. In this case, it retrieves a whole series of hits. Here are all the suppliers listed, the catalog IDs, the size, the amount of material available, the cost, and the purity. And in actual detail, you might want to click on each of the individual vendors, and it will bring up the details for each of the various countries, in this case for Sigma Aldrich. Because we're sourcing some of the detail directly out of ChemSpider, we of course have a link to the ChemSpider ID here that will take you over to the ChemSpider site and give you access to the usual information that you'll find on ChemSpider. And we've even provided a link to search Google Scholar. So in this case, it's going through articles using all of the synonyms associated with this chemical that we host on ChemSpider to give you a complete search. We also have, as I said, structure and substructure searching. So in this case, what we will do is draw a particular chemical. Let's imagine, for example, that we want to search this particular trichlorobenzene. Perform the search. In this case, we'll do an exact search. And in theory, we should find this chemical again on the EPSRC available chemicals directory web service, trichlorobenzene, 1,2,3 trichlorobenzene, with the list of the suppliers. ACD iLab, Advanced Chemistry Development Interactive Laboratory. The premise of iLab is very simple. You have the ability to upload a chemical, and you can either draw it or convert the name to a structure or upload a mol file, for example, and then search across a series of databases, physical property databases, NMR databases, etc. Alternatively, you can draw a chemical, novel chemical, one that you may be synthesizing, working on, studying, and then generate properties. These can include things like systematic names, physical chemical properties, ADME, toxicity, or NMR. As an example, rather than draw volume, I'm going to look it up in the ACD Labs dictionary. So I type in the name, it tells me it exists, it's retrieving it from the dictionary. This is the chemical structure, here are some of the properties that it's calculated, and now if you look over on the left hand side, you see the various modules. Let's start with something like naming. I want to generate a UPAC name. Here's the systematic name. I can download the report. There are various options that I can use. Many of these you may not even be aware of in terms of what you can set for generating names. Many of you will simply just want to generate the systematic name. However, next I may be interested in predicting an NMR spectrum. So in this case, I open the NMR modules, I calculate the carbon NMR spectrum. This is using algorithms that have been reported in a number of peer-reviewed publications. It's a well-proven software platform. And here you see the chemical shifts, the errors, and the coupling constants. And you can see a very interactive, rich interface here, where I can zoom in, and as I hover over a particular resonance, you can see the interaction between the table and the actual nucleus highlighted on the molecule. So that's carbon. We also have the ability to search through the databases, so we can open up the databases directly. These contain hundreds of thousands of chemicals, and these can be searched. We can perform exact structure searches, molecular formula searches, references, etc., etc. This will all be covered in a later display. Let's assume that we'd like to calculate a log p-value. We simply open the physchem properties, and here we see the log p-value is calculated. There's a lot of hover boxes that give us information about what each of the values is. You can see here the experimental values for similar structures from the training set that has been used to deliver the log p prediction algorithm. Similarly, we can calculate pKa's, solubility, etc., etc. We've also included at release access to a number of other databases, primarily because we'd like to get feedback from the community and their value. These are ADME databases and toxicity databases. We'll cover each of these in a separate movie. Hopefully you can see the benefit of having access to a platform that will allow you to both search against high quality curated databases, as well as to provide access to the prediction algorithms that are used in many, many pharmaceutical and chemical companies today. Access to the ICSD, the Inorganic Crystal Structure Database, will be available when the Chemical Database Service goes online. This is probably a database that many of you interested in this particular field of chemistry already have access to, and we're providing access to the web-based version of the database at this point in time. Moving forward, we will be developing a different interface to access all the various forms of crystallographic data that we have access to. When you click through, you will see that you are now logged into the ICSD, and the basic capabilities that you're used to accessing in terms of search are available. For example, on the chemistry side, imagine we want to search on sodium bromide. It's the typical result set that you would expect from the ICSD. The web interface should suffice at this point for people to access the ICSD, and as I commented, we will be providing different forms of access in the future as we develop new interfaces. I've shown you an overview of what we will be delivering at release in January 2013. Moving forward, we intend to roll out new capabilities, new databases on an ongoing basis in the next few months. Certainly we hope to engage the community in discussions to see what they feel is most of value and balance that against what we expected to deliver as a result of responding to the initial tender. However, I want to make sure that it is understood that the future capabilities that we will be building are going to be very different to those that were previously in place for the previous chemical database service. The previous incarnation of the CDS delivered access primarily to commercial databases as well as to some of the prediction tools. However, technologies, expectations, and certainly policies around data have changed over the years, and there is an expectation today around data availability. This 5-year project that we're engaging in will not only deliver access to commercial databases and prediction tools, for example, but will also include the development of new capabilities to support some of these new policies and expectations. In particular, the EPSRC, the funding body for the CDS, have a specific expectation around research data management. In the work that we will be doing, we will ensure that data will be managed under embargo if necessary and as appropriate, and then made available according to the funding agency policies. The CDS will provide an environment for the community to engage in reviewing the data that we will deliver, whereby the community can annotate the data, curate, and of course deposit their own forms of data. We have experiences in this domain because we've been doing this type of work on ChemSpider for a number of years now. The data that will show up on the data repository will also be of value because they may be able to contribute to expanding the data sets that underpin prediction models. For example, if the community contributes aqueous solubility data or log-P data, maybe NMR data for prediction purposes, then we'll be able to enhance prediction models. We also live in a period whereby scientists are being measured in different ways. This is the domain of alternative metrics. And certainly we hope that by providing a place for scientists to store their data, to participate in the curation, annotation, checking of the data that are available on the CDS system, that we'll be able to track their contributions and also feed that information out to the domain of alternative metrics to truly measure where scientists are contributing, not only through peer-reviewed publication, but also in terms of their data contributions. We will adopt new standards, such as the Open Research and Contributor ID, the ORCID, and this will help us associate all the data that's necessary to feed the altmetrics tools that are becoming available. We will, of course, be integrating existing technologies. That's how we will get the system moving. That's how we'll be able to deliver something very quickly. In just a few weeks, we've been able to bring together a number of databases and platforms in order to deliver the system in January 2013. But moving forward, we intend to deliver both personal, group, and institutional chemistry data repositories. We do intend to deliver the ability to provide SAR modeling, structure activity relationship based modeling, from deposited data from the community as well as from data that we will pull from the ChemSpider database. We will do our best to provide federated searching across multiple databases. We'll also provide a micro-publishing platform for research data. For example, you may be aware of the ChemSpider Synthetic Pages platform that we've discussed earlier in this video. That is already a micro-publishing platform for chemical syntheses. Of course, future developments will depend on priorities that have been provided to us from the community of users, and we look forward to engaging you in those discussions. What I show here is not the interface that will be available, but just a segregation of data that may feed into the future vision for the chemical database service. Clearly we have ChemSpider as one of the community's richest online sources of data for chemists. We can imagine various types of physchem data, ADME-tox data. We're already gathering spectroscopy and crystallography databases together, and we're about to deposit the NIST mass spectral database onto ChemSpider and feed it out to the CDS. We've already got Sprezi Web integrated, and we're also building up the ChemSpider reactions database. We'll provide a way to access health and safety data, and of course predictions and models will be made available not only through the ACDI Lab platform, but also through work we are doing presently with Pipeline Pilot from Accelerus. And of course we will give you a way to access your personal data, your institutional data, and the profile will allow you to map all the accessibility that you may have to other RSC, online articles, etc. The chemical database service that we will develop in the coming years is a work in progress. While the initial stages of the project will replace some of the capabilities that have been available to the community over the past few years, the intention clearly is to build something much bigger, much more powerful, and much more encompassing to the world of open data, open science, and for data exchange between parties. We hope that you'll join us on this journey. Please follow us on Twitter. Feel free to email us at the address shown, and follow us on the blog. We look forward to working with you.